And that was Neil Young singing Fuel Line, and you are listening to The Wild Side on Source 96.1 FM. And as you might expect by listening to that song, we are talking about fuel today. And specifically, we're talking about fossil fuels and alternative energies. And this was something that I thought might be an interesting topic because you hear alternative energies being talked about all the time, and it's something that actually is studied in great detail up at the Tremont campus where I work at the University of Exeter. And I realized the other day that even though this is such a catchphrase, and that it's something that's a really big concern, and we vote on issues associated with this, and we make decisions in our personal lives associated with this, I actually don't really know that much about the science behind all of these things, and I certainly wouldn't know enough to make really good, informed decisions. Or at least I should say, I didn't really know enough until I started reading around a bit this weekend. So I am going to share with you what I found out about fuel use and the current energy sources that we have, and some of the potential alternatives that are and potentially will be available to us in the future. So just to kind of start at a very basic level, what is fuel? Well, it's material from which stored energy can later be extracted, and hopefully this will happen in a nice, safe, controlled manner. Sometimes fuel is used purely for heat, so for example, if we are burning a fire just to stay warm. Sometimes it can be used to change something from one state into another, so maybe you're cooking or you're doing some sort of metalworking. And sometimes fuel is used in order to drive mechanical processes. So for example, if you've got a windmill, you can use wind as a sort of fuel that will move the windmill around and turn turn wheat or some other kind of grain into a flour. And the current most common fuels that we use are biofuels, which means that they are derived from organic materials, from biomass. Now, we rely particularly heavily on fuels that are made of hydrocarbons. And these are things like wood, which was used for fire for at least 1.5 billion years ago. That was when it was first emerging as a source of energy for humans, and potentially even maybe earlier ancestors of humans. Also things like charcoal, which is a derivative of wood, and it's been used for energy since about 6000 BCE. Coal is another important source of energy. It's been used since about 1000 BCE, and it became particularly important in the mid-18th century with the development of the steam engine and, of course, the Industrial Revolution. Something else that became quite important at that time was coke, and coke is derived from coal, and it's prominent from about the 18th century onwards because so many forests had been cut down by that point that people were interested in finding an alternative source of energy, an alternative to wood, and so they turned to this byproduct of coal instead. And of course fossil fuels, which are popular from about the 19th century onwards as a result of the Industrial Revolution. And these of course are very flexible and quite powerful. And they're made from the fossilized remains of plants and animals. So I already mentioned coal, but also important are petroleum and natural gas. And all of these things were created when biomass underwent anaerobic decomposition, so there was decomposition of these things in conditions where there's no oxygen. So there are only certain types of decomposers that are able to drive these sorts of reactions because they had to be able to go without oxygen. They also had to be able to withstand very hot and quite high pressure conditions in the Earth's crust. In fact, it can take anywhere from millions of years to hundreds of millions of years for this to happen. Now, a recent study found that fossil fuels were responsible for over 2/3 of all of the energy consumed by humans. The most important of all of these is petroleum, and then that's followed by coal, and then by natural gas. Now, one thing you don't often hear about fossil fuels is that they actually have done lots of really good things. So, relatively speaking, when you compare them with other sorts of fuel, they are pretty cheap, they're pretty easy to get a hold of, and they've also been credited with saving time and labor, and because of those things, improving the standard of living around the world. The existence of these things and the ease with which we can get a hold of them is the reason why we have the sorts of technologies that we have today, and many of the other kind of aspects of our society have been driven by the fact that we have access to these things and can live a relatively cushy life because we do have this cheap and quick and very available source of energy to fuel all of the different types of things that we do. Additionally, fossil fuels have lots of byproducts that can be utilized in other ways, and so it tends to be kind of an efficient sort of process. So for example, when you burn coal, you produce ash, and that ash can then be used in road construction in order to kind of help with the binding of the cement and to give some body to the cement. And so in a way you're kind of killing two birds with one stone, and this actually can be quite a good thing. However, of course we know that there are also lots of things that are wrong with fossil fuels. Now, one of the problems associated with fuels is political. Some people have more access to these things than others. Also, fossil fuel jobs can be associated with really horrible side effects in terms of health of workers. And also some areas use more than their fair share. So for example, my home country, the US, uses much more energy than it should per person, given kind of what everyone else around the world does and how much of that energy is actually originating from within the US itself. So you do have lots of kind of political and in some cases economic sorts of considerations that you might associate with the use of fossil fuels. But there are, of course, also some scientific issues, and that's what I want to focus on today because that's something that I'm personally much more qualified to comment on. So of course fossil fuels are considered a non-renewable resource. And that means that, once you have used them, then they aren't coming back in another form that you can use again. So it's not something like wind that's just going to kind of keep circling the globe. It's not something like trees that are going to keep replenishing themselves and growing from one year to the next. Once you burn fossil fuels, you can't really ever recapture them in some way and kind of have a self-generating and self-sustaining process. And indeed, they are not a sustainable source of energy. And they take millions of years to form, as I already said, and we are depleting the stocks incredibly quickly. And so, in fact, we are depleting them faster than they're being replaced. And some recent estimates suggest that we have approximately 150 years of coal left, maybe 43 or so years of oil, and about 60 years of natural gas. But those estimates, there are lots of estimates, I've just chosen one of many, those assume that current levels remain static. And what we actually see is that world energy consumption is increasing each year because the human population is increasing and we are increasing our levels of industrialization and urbanization. And so that means that actually we're probably going to run out of things more quickly. In many cases, for instance, people my own age, some of this might actually happen within our own lifetime, and it certainly will start to happen by the time that we have children and grandchildren. And something else that a lot of people don't tend to talk about is the fact that even once you do still have reserves, they're just depleted, actually that depletion, that lowering of how much you have as opposed to completely using all of it, that's still going to have a negative impact. So you might have so little left that it's going to be really difficult to access and it's not going to be very cost effective. So even if you've still got 5% of all stores left, that actually could be just as damaging as having 0% left. And another concern about fossil fuels is, of course, that they're not clean. They generate billions of tons of carbon dioxide per year, and only about half of that can actually be absorbed by the environment, by trees, for example, and by the ocean. And the remaining 10 billion tons or so end up going into the atmosphere. And these are the things that help contribute to the climate change that we are also worried about and that I discussed recently here on the show. Fossil fuels also contain pollutants, things like nitrogen oxides and sulfur dioxide, and those contribute to acid rain. They contain volatile organic compounds, and these are things that can cause a lot of damage to organisms. So, for example, they can cause mutations in the body. And also they have things like heavy metals, and everyone knows heavy metals are to be avoided. That's one of the big worries about having lots of seafood in your diet. So fossil fuels also can contain radioactive materials. So anytime you have got any sort of event in the history of time where there's any sort of radioactivity left over, whether that was some sort of a previous nuclear disaster and the byproducts have kind of filtered down into the fossil fuel supply, or whether that's something that happened a really long time ago as the Earth was being created and as all that geological activity was occurring. Whatever the case may be, there's radioactivity left over in these fossil fuels, and so when you burn them you can release that into the environment. And of course, the extraction of fossil fuels is also associated with environmental damage, and this is a real issue where I come from in Ohio in the United States, and it's something I've talked about recently on the show when I mentioned the Wilds, which was a place where they used to do some really extensive surface mining. So things like mountaintop removal and strip mining and offshore drilling, all these things, pollution associated with oil refineries, and whenever you've got a ship, a tanker that might leak and pollute oil into the water, all of these can reduce biodiversity, and they can degrade the habitat, and they can cause other problems to the environment that are very long-lived. So it's not just something that happens now and can cause some issues with what's around now, but it can have permanent impacts, or at least very long-term impacts on a habitat, and make it very difficult to recover and bring the wildlife back in. And so because of all of these different problems combined, we are interested in looking at alternative sources of energy. And that's something that we're going to talk about a bit more after the break. Welcome back to The Wild Side on Source 96.1 FM. You are listening to an episode on energy and alternative fuels, and that was just Clare Maguire singing You're Electric. Now, alternative energy, as the name suggests, is any source of energy that can be used in the place of a less desirable source. And you might want to do this because of the cost, or ease of access, or environmental consequences, or maybe some combination of all of these things. And our current interest in moving away from carbon-based fuel is actually only the latest type of alternative energy. So during the Dark Ages, for example, Europeans had cut down so many trees that they didn't really have any wood left around. It wasn't very easy to get where it did exist, and so they turned to coal as an alternative to wood. Again, in the 19th century, we found whalers depleting the whale population so extensively that they no longer had whale blubber to use for lubrication and for fuel, and so they turned to petroleum instead. And finally, another good example, of course, of what we're undergoing today was actually something that was initiated quite a long time ago. So from the 20th century onwards, people have been interested in finding alternatives to coal and oil. And very early, in the first couple of decades of the 20th century, people were realizing that maybe there were some potential sources of energy that might be a bit better for a variety of reasons. And one early advocate of alternative energies was Alexander Graham Bell, who you might know as being an inventor. But he was quite interested in finding a way to use crops to make ethanol. And of course that is something that we now do today. So he was quite a bit ahead of his time in realizing that that was a possibility. Now there are many types of alternative energy that are currently in use, and there are others that are being developed and perfected, and some that have been proposed but aren't really feasible quite yet. And many of these are in fact non-carbon based, which of course is one of the most important things if you want to move away from these kind of biomass type fuels. But they're also renewable and ecologically friendly in a variety of ways. So they may not have as much pollution, they may not have as big of a carbon footprint, they may be a bit friendlier for the whole ecosystem, or again, some combination of these and other things as well. So now I have basically a list of all the most important ones, and I'll go through and kind of explain a little bit about how these sources of energy work and why it is that we might be interested in using some of these. So first on the list is solar energy, kind of the most important alternative energy because it is in fact the thing that pretty much fuels everything on Earth already in some form or another. And you might remember that from one of my previous shows when I talked about how sun is what is used by primary producers, so things like plants and algae, in order to run their own selves, and then they are eaten, and this helps run the herbivores and the carnivores. So really the sun is important for those fundamental processes of making all living things, and also the sun provides all of this heat and warmth that's absorbed by the ocean and the land, and this drives a lot of the patterns that we see in terms of weather and climate. So you really can't beat solar energy in terms of having a big impact, because it is really the thing that kind of helps make life on Earth possible. But we also can use it more specifically to generate heat and electricity and help kind of wean ourselves off of fossil fuels. And you can do this in a couple of different ways. So there are both passive and active solar techniques. And passive techniques include things like orienting a building towards the sun, selecting materials that absorb heat particularly well, or hold it for quite a long time after the sun has gone down, and also architectural ideas that kind of facilitate the flow of energy that has already been captured. So you can arrange your buildings in such a way that you have heat that's moving from one place to another, or bringing heat in from the outside and distributing that through the home, or keeping out the cold and insulating things quite well. So lots of quite simple solutions actually to just taking advantage of what you've got and not letting it drain away too quickly. Now in terms of that orientation thing, this is actually something that we see happening among animals out in the wild today. So the birds that I've mentioned before that I studied for my master's and my PhD work, these guys are cavity nesters. And a lot of cavity nesters, like these bluebirds and other species related to them, they tend to be really choosy about the sorts of cavities that they live in. And one of the things that they are interested in doing is finding a cavity that's facing in a direction that will get the most sunlight during a day. So these guys are aware on some fundamental level that you can choose a habitat, choose a little cavity that will allow you to maximize on solar energy. And the Romans were also quite aware of this, and they used to design their buildings often with something called an oculus at the top. And that's basically kind of like an eye-shaped sunroof, really. And it allows light and heat to come in. And that's something that warms the place, and of course they didn't have electricity back then, so this is quite nice for also providing light rather than having to use candles. And of course it can be quite a cheerful thing as well, so it does have lots of different uses all rolled into one. Now active solar techniques are probably what we think of most of the time when we think of using solar energy. And down here, for example, in Cornwall, we do see solar panels all over the place, which really is very optimistic when you consider Cornish weather. But it is a great thing to have these photovoltaic panels. And these guys are collecting the heat and the energy of the sun, and they're turning it into something that we can use to generate electricity. So photovoltaic panels, also called solar cells, were actually first constructed in the late 19th century. So they've been around for quite a while. And these convert light into electric current by taking advantage of something called the photoelectric effect. And this effect, basically what happens is that electrons are emitted from matter after they absorb energy from electromagnetic radiation that has short wavelengths and high frequencies. And basically what I'm describing there is ultraviolet radiation. And so you can make these panels of these materials that emit electrons, and then those electrons, as they're emitted, can be, the energy from that response can be captured and then funneled into driving the electricity of a building, or heating that building, or whatever you want it to do. And amazingly, as complex as these things are, a few years ago I saw something about a Native American boy living on a reservation in the U.S. who had managed to build a very efficient solar panel using nothing but old bottles and filling them with water and using other scrap bits that he found around his reservation. And actually he was able to build these on several different buildings and help his family members use solar energy in order to run their homes and cut down on their electric bills. So actually, as expensive as these things are and as complex as they also can be amazingly simple, and you can be quite innovative about how you build them and where you put them. Now another quite nice natural source of fuel, of energy, is the wind. And I already mentioned it before when I talked about windmills and how we used to use these quite a lot more than we do today, but you do still see them around. And basically, you can take advantage of the fact that as the wind goes past, you can rotate something, and that in turn can kind of rotate something else. And if you put, for instance, wheat underneath that, then you can end up with flour. But of course, when we think about wind energy today, we probably aren't thinking of windmills so much as we are thinking of wind turbines. But in fact, you can go even before windmills and think about really fundamental and kind of simplistic forms of wind energy. And sailors have been known to use wind to move their boats for thousands of years. And Greek engineers used wind to power some of the first machines that are known of. And these date back to the 1st century of the Common Era, so actually, quite a substantial history of using wind energy. And windmills were first developed in the 9th century in Iran. So humans have, for quite a long time, been aware of the power of the wind and have developed lots of different ways to harness that power. Wind turbines, as we know them today, were patented in the late 19th century, and the very first turbine, actually it was quite a whole array of turbines, they all were joined together and they were used to fuel a lantern at a building in order to show off the power of this new technology. And of course we can get quite a lot more bang for our buck these days. But it does have quite a nice history. The wind turbine has been around for a while, and now we tend to see them all over the place in the form of wind farms. And these, of course, are aggregations of lots of different wind turbines all together, and they're generally used to generate energy, although that energy can also be used to then go on and make heat. And wind farms are located both on land and offshore, and one of the advantages of having them offshore is that the winds there are generally stronger and more frequent than they are on the land. And also turbines are often thought to be quite unsightly, and so if you put them offshore they aren't going to be seen by quite as many people. However, at the same time, these ones that are associated with the ocean can be more expensive to build because of access issues, and also to maintain because of the corrosiveness of the salt water. And there are nearly 100 countries around the world that have commercial wind power facilities, so this is something that is picking up and is spreading. Some countries, for example Denmark, may get substantial amounts of their energy from turbines. So Denmark gets about 25%, and that's the highest, and there are others that get something around 10%, 15%. So not an insignificant amount of energy coming from wind in these quite breezy, open areas where you can have quite easily vast arrays of these turbines that all can contribute to the national power grid. That was When the Lights Go Out by the Black Keys, who you know I have to sneak on here as many times as I possibly can. And they were singing about lights going out, but hopefully that won't happen because we have all sorts of different types of alternative energies available, and that is what we are talking about today here on the wild side. So the next type of alternative energy here on my list is geothermal energy, and that is where you use hot water or steam from the Earth's interior in order to produce heating or electricity. And in this case, the energy comes from energy that was around during the original formation of the planet, so that makes up about 20% of all this geothermal energy, or it comes from the radioactive decay of minerals, which is responsible for about 80% of the energy. And I have to say that this was something that really surprised me because I just never really thought of where the heat came from. I just kind of knew that the Earth was really hot in the center and that sometimes that heat percolated out, but it never occurred to me that that heat was generated when our planet was actually first made, when the solar system was forming. And then also you've got all these minerals that are cramped down there underneath all these different layers, and they're in all this pressure in this hot environment, and you have all this radioactive decay, and that is what causes all of the heat from the geothermal energy, which is just amazing. And all this heat eventually makes its way from the core, where it can be over 5,000 degrees Celsius, up to the surface, and that happens because of the geothermal gradient. So basically, I talked a little bit about entropy before, and we know that places that are quite warm, you're going to have that heat percolating through to places that are a bit cooler, and this all has to do with some kind of complex physics that I'm not going to go into again because I did speak about that previously, but we know that because of this you are going to have heat always going from where it's warmer to where it's cooler. And so that's what causes this geothermal gradient, where we've got the heat from the core eventually working its way through each of the layers of the Earth and eventually making its way out onto the surface where we can take advantage of it. And in fact, this is something that humans have taken advantage of for a very long time. So there's evidence that the Paleolithic people, so we're talking tens of thousands of years ago, would have used geothermal energy while bathing, so basically they would find hot springs. Romans used it to heat their buildings, and they had some really amazing setups, some of which you can actually see right here in Britain, where they would have their buildings built on top of places where the heat or the steam were coming out of the cracks in the earth, and so they would kind of build their buildings up on little stilts over top of that and take advantage of having that heat underneath the floorboards and allow it to percolate through the rest of the building, the house, whatever it might be, and keep everyone nice and warm and cozy. And it's really amazing to see how the Romans were able to use their architecture to take advantage of this natural source of energy. And now when we think of geothermal energy, we're usually thinking about using it for electric rather than for baths, although that is quite pleasant if you can find a nice warm spring, or for heating. And where this is most common, as you might expect, is where you've got tectonic plate boundaries. So this is where you do have these really obvious big cracks through which all the heat and the steam can emerge. However, we do now have the kind of technology that allows us to harvest energy from these places and kind of pump it out across greater distances. Now, Iceland is currently the world leader. This is probably not surprising to you if you've ever seen pictures of Iceland and know much about their geology, because they do have quite a lot of volcanic activity, as we found out not so long ago when there was that horrible ash cloud. And they have about 90% of their homes heated with geothermal energy. And the capital of Iceland, Reykjavik, and I'm sorry if I have totally mispronounced that, is actually one of the cleanest cities in the world because of its use of geothermal energy. And in the past, it used to be considered one of the dirtiest because of all of the pollution there. So using geothermal energy can be a big step up in terms of having a cleaner environment. Now, another thing that you'll often hear talked about as a really important alternative source that there's quite a lot of money and interest in right now is biofuels. And biofuels are plant-derived substitutes of gasoline. So basically we're creating our own petroleum. And what you can do is transform carbon dioxide into organic compounds. And it's the same kind of process that you have during photosynthesis, but you're kind of encouraging it or facilitating it on your own rather than waiting around for it to happen naturally. So one example of a biofuel is bioethanol. Again, this would make our inventor friend quite happy. This is what Alexander Graham Bell was dreaming of. So you can take corn or sugarcane or some other crop and turn it into a source of ethanol that you can then use to run, for instance, cars on. And often we find this used as an additive to petroleum that we're already using in our cars, but you can also use it in a pure form. And this was actually something that I saw firsthand when I went to Brazil, and we had a rather harrowing taxi ride from where we were staying to get to the airport. And of course, when we were running out of time, our taxi broke down and he had no gasoline left. And he ran off to the nearest place, which unfortunately was not that close. And he came back with basically a bottle, like a gallon jug of just pure ethanol. And he poured that into the tank, and we did get to the airport in time. So I can confirm that not only will a car run, but it will run very fast. It will run at airport speeds down the highway. Now, other sources of biofuels include cellulosic biomass, and these are derived from non-food sources such as trees and grasses. So that's kind of the same basic idea as with the bioethanol, only you're using stuff that has a lot more cellulose in it and is not quite as easily digestible by animals. So it does hold quite a lot of energy, but it's much harder to get out. Now, biodiesels are fuels that are made from vegetable oils and animal fats. And again, these are also usually an additive, though they, again, can also be used in a pure form. And one of the really exciting and promising things is algal biofuels. And here, a lot of researchers are focusing on utilizing algae that have a large natural oil content. So if you think of an individual algal cell, it's not really that big. But if you have one that has quite a lot of oil, and then you grow up huge colonies of it, and harvest them and press that oil out, and then dry the remnants and then use those to make ethanol, you could see how feasibly you could actually start to accumulate lots of fuel over time. And in fact, there's also a lot of interest in doing some kind of genetic work to increase the rate at which the algae are producing these sorts of oils that are useful, increase the rate at which they turn over and reproduce so that you can maximize how much algae you have available at any given time. And just a couple more left here on the list to run through. Something that's quite interesting around here, because we do live on the sea and also quite near to terrestrial sources of water, is hydroelectricity and hydropower. And these use energy from the flow of water, and basically they both take advantage of gravitational forces. And these are, in fact, the most widely used form of renewable energy. So Tidal power is amazingly the only technology that's rooted in the relationship of the Earth to the Moon. And of course, the Sun does also have some impact on the tides, but it is predominantly the Moon that drives the activity of the waves. And all the other stuff I've talked about, it has a lot to do with the Sun. The Sun is growing up, for instance, the algae. The algae use that energy from the Sun to reproduce, and that's ultimately then where you get the biofuels from. It's a product of the energy from the Sun. The same can be said of fossil fuels. But with hydroelectricity and hydropower, and the movement of the tides when you're thinking about tidal power, that's something that really is being driven by the Moon. And in fact, this type of energy, this pull of the Moon, is so powerful that it has actually caused the rotation of the Earth to slow over time. And I know this is a bit tangential to what we're talking about now, but it's really amazing. It helps put things into context. So during the last 620 million years, for example, day length has increased from 21.9 hours to 24 hours. And this represents a loss of about 17% of all the energy of the rotation of our Sun. So if you think about all of that energy, it's huge enough to cause our Earth to rotate more slowly. And so I think that's quite a good sign of how much potential energy then is in the action of the waves and is in hydroelectricity, because this is something that's being driven by this incredibly powerful force that we look at up in the sky and think is quite pretty, but we kind of forget how really important the Moon actually is. Now, the first hydroelectric power scheme was developed in the late 19th century. There was a whole lot going on at this time. I've mentioned coal and coke and all sorts of things at this time. But they also, even that early, were looking into these alternative sources of energy. And actually, you'll be proud to know that this first power scheme was developed right here in the UK, up in Northumberland. Now, non-tidal sources of water energy are most commonly associated with dams. And basically what happens is that you're harnessing the potential energy of the dammed water. And again, you're taking advantage of gravitational forces, but in this case it's not the pull of the Moon on the waves, it's the pull of gravity on the water. So normally dams are kind of set on a precipice, so you've got a whole lot of water that should be cascading over and falling down, dropping down quite a large distance, but they're not. And all that pressure is building up and it runs the water up next to the wall, and then what they have at dams is basically kind of a tunnel that sends that water that's at high pressure, it sends it shooting down that tunnel, and then it drives a turbine, and that turbine is attached to a generator, and that's what allows you to harvest energy from this movement of the water. And you've got kind of a similar thing happening with the tidal energy. So you've got a tidal generator that's able to convert energy from tidal flows. And in this case, we're not channeling the tide through a funnel that goes underground, but instead you're taking advantage of the fact that it's naturally going to change its height, it's going to change its intensity, and you can translate that into electricity. And as you might expect, the more tidal variation you've got, and the higher current velocities you've got, the more electricity you can generate. And so tidal energy is going to do particularly well in areas that have very rough, choppy seas quite often. That was McCue singing Bright Light of Day, and you are listening to The Wild Side on Source 96.1 FM. And I have one last type of alternative energy to talk about before we can move on and think about maybe some of the drawbacks associated with all of these things that so far I've been lauding quite highly. And that last thing that's on my list is not actually the last thing. There is not an exhaustive list here for me to read off to you, because there are lots of other sources of potential energy, and I can't spend all night talking about them. But I've just wanted to highlight the most important ones for you guys. And this last one is nuclear energy, so I'm saving one of the most contentious for last. And nuclear energy takes advantage of something that's called nuclear fission. And fission occurs when you take a nucleus and you split it into smaller parts, because doing that releases a whole lot of energy. And so nuclear energy can be used to generate both heat and electricity, pretty much like all fuels. And what happens is that you've got a nuclear reactor in which all of this is happening, and you have the nuclear fission occurring within a place where it can generate all of that heat, and then you translate that heat into steam, basically, and drive a turbine. So it's kind of like these other things I've been talking about in the end, but you just start off with this kind of, I won't say unnatural exactly, but it's something that we certainly don't see happening on quite this scale very often on Earth. So basically, if you've got the fission taking place and you generate all of that heat, and then you suddenly subject all of that to a cooling system, then when you've got the cool water meeting this very hot area, then it's going to generate a whole lot of steam, and you can funnel the steam up so that it drives a turbine that's attached to a generator, and then you can harvest all of that electricity that is generated. And the most common source of fuel is uranium-235 and also plutonium-239, but technically you can pretty much get nuclear energy from anything, because all you have to do is just take a nucleus and split it, but it does take quite a lot of energy in order to set off that reaction if you just take any old thing. But if you take something that's already kind of prone to splitting up on its own, then it's much less work for you to start that reaction off. And currently we have about 450 plants worldwide, and in total they're responsible for just about 15% of the globe's electricity. So nuclear power isn't something that is really that common and is taking over, but it also produces a fairly substantial amount of the globe's electricity, and certainly a big part of all the alternative energies that we see in use today is in fact nuclear energy. And despite the fact that there is quite a lot of fear about having meltdowns associated with these nuclear power plants, actually this method is associated with the best health record of all the other sources of power if you look in terms of lives lost. And I say that even though we have, of course, had quite a recent event that turned out very badly, and that's the Fukushima disaster. So I'm not sure how that might add into these figures. But all these other things that we get energy from, they are associated with lots of deaths and health problems in various ways. And so actually nuclear power does have that to its credit, whatever else you might want to say about it. And in fact, this is a good time to say some of those other things about it, because as important as it is to think about alternative sources of energy and to think about all the things they could offer us, there are many disadvantages associated with these other types of things that we are trying to move into using more. So solar energy, for example, is obviously not going to be good at certain times of day, like the nighttime, or certain times of year. So for example, the winter, especially around here when you're up kind of high in the north or very low in the south, when you've got quite short days during part of the year, then you're only going to have a little bit of sunlight that you can have access to. And that means that you're going to have to really harvest the energy very efficiently, store it quite efficiently, transport it quite efficiently, and right now we don't necessarily have the ability to do all of those things. It also can take quite a lot of money to set up solar systems, by which I mean solar energy systems, not solar systems as in out in the universe. Of course, these things also can generate their own type of pollution, and you might not think about that, but in fact, the materials that solar panels are made of actually can degrade and cause problems in the environment once they're no longer in use. And one ingredient of some solar cells is cadmium, and this is known to be toxic. And there are some worries as well that if you're taking all of this energy from the sun and turning it into something that you can use, that you're taking it out of ecosystems that might have used it for some other more natural, if you like, purpose. And so potentially you could have lots of large-scale effects of taking all this sun and diverting it from where it might normally have gone. With wind energy, you do also have kind of some similar constraints in terms of not being good for certain areas or certain times. In particular, this is very obvious, it probably goes without saying, that if you want to use wind energy, you need to have wind. And so if you've got certain weather conditions where it's quite still, or it's very unpredictable so you don't know when to have the turbines running, then maybe you aren't going to be able to take advantage of wind energy. Also, the spinning of the blades can be very damaging to both bird populations and bat populations, and that's because they cause physical damage if the animals fly into them. It's also barometric damage, so the blades do whirl so quickly that they can change the air pressure, and they found that in lots of bats they have all these problems in their ears and in their lungs where the air pressure has changed so suddenly that it's burst vessels, and it actually can kill them. And offshore wind farms can be particularly bad for the environment because of the techniques that are used to install the turbines. So it can be quite disruptive to go in and dredge and place these things out in the bay. And so, as I said before, you also are subjecting all these things to the corrosive salt and seawater, and this is going to mean you're going to have to frequently need to replace them or fix them, and this again is going to cause disturbance to the habitat. And also, as I mentioned earlier, there are some aesthetic complaints about these things, though I think probably those would be very much outweighed by the potential good that turbines could do. Now, geothermal energy can be associated with greenhouse gas release, though even if it is, it's still quite a bit less than is released in the burning of fossil fuels. Unfortunately, only a limited number of areas can be exploited very profitably because you do need to take advantage of these fissures through which all the heat and the steam are being released. And if you need to try to drill and get access to deeper or additional resources, that can be incredibly expensive, and it's just not going to be really cost effective in order to go in and try to get access to those sources of heat. And potentially, as with the sun, there could be some ecological and even geological consequences of removing all this heat from the ecosystem. You know, it's in there doing things and kind of, there are these normal patterns and processes that have been going on for millions of years, and if we go in and start funneling all the heat away, it might alter things in some fundamental way that we couldn't predict very well. With biofuels, you have to think about the trade-off between using land to grow biofuel crop and using it for growing food instead. And you also have to be concerned with the fact that if you've got a field in which you're growing all these crops, that means you're probably going to have a loss of biodiversity because you're making it quite homogeneous, you're putting in all the same crop, and you might lose some native species that would have lived there originally. And unfortunately, biofuels aren't 100% clean either. They are still responsible for carbon emissions, even though they are better than fossil fuels. And they're also not sustainable, or at least many of them are not very sustainable, because you have these kind of genetically modified crops and they die out after a while, they deplete the soil, so you have to go in and do certain things in order to keep those crops going over time. With water power, we all know that disruption of the natural flow of water can have impacts on the ecosystem. This is something you've probably seen at some point in your life if you've ever gone to a dam, or if you've ever found out about a river that's been diverted, maybe because it's overflowing. Having all these effects on the hydrology can have really wide-ranging repercussions for the ecosystem. You can change the amount of water that's available to wildlife. You can change the sediment flow, and the sediments contain nutrients, so that can change the growth of organisms later on in other places. You can impact the migration and the movement of aquatic animals. And also, if you want to look at this from purely an economic perspective, the startup costs can be incredibly expensive, just as with the turbines. Anytime you're installing something out in the ocean, out in the water, out in deep areas, it is going to be quite a hassle to transport everything there and get everything set up. And finally, with nuclear energy, not only do you have amazing expenses, so this is actually one of the most expensive things to set up, but also nuclear energy generates toxic waste, and as I mentioned earlier, it can result in meltdown. And this is not something that's really likely, but it can still be catastrophic, as we've seen with events such as those that happened in Chernobyl and 3 Mile Island. So basically, you have to think about all the pros that I mentioned earlier and all of the cons that I've just gone through, and you have to weigh all of these when you're deciding which source or different sources of energy to invest in the future. And as you can see, it's not really a clear-cut issue. Everything has some goods associated with it, and everything has some evils associated with it as well. And the problems associated with all of these choices are one of the reasons why people are so interested in developing alternative energies, so things like hydrogen power, that's considered to be the cleanest of all things because its only byproduct is water. So maybe one day we'll find some other sort of efficient and renewable and sustainable options that have nothing but good things associated with them. And on that very optimistic note, I will leave you with Frowley singing The Light.